Welcome back to my channel, Conquer the Fear. Are you struggling with the messy, hard to maintain Java code? Are you tired of writing the long loops, complex logics just to maintain or manipulate the collection? What if I told you there is a better way to simply to do all these things? Imagine you are transforming your code into something cleaner, faster, and far more efficient at all once, just with a few simple steps. Now Java Streams hold the secrets to writing the code that only not only works but also works better and smarter. So, are you ready to ditch the old clunky approach and discover how to leverage the power of stream to make your code smarter? So, let's unlock these game changing features together. So, let's begin. So, first of all, we need to understand what is Java Streams. Okay, so Java Streams, as part of Java 8 version, it was introduced, and it will provide a new abstraction way of working with sequence of data in functional style, basically. So earlier, when in Java basics, right, when we used to deal with the collection, we used to operate that on the exact collection. Okay, so we used to perform the operation directly on those things, but when it comes to stream, it is not only a data structure by themselves, but they're going to represent some sequence of elements that can be processed. Okay, so it will not directly work or apply your changes on that particular original collections or the input. It will create a copy and then work on it. So we'll look into what exactly stream is going to allow you to do. Firstly, it is going to do a lot of different operations. That is, first is filtering. So you can filter based on some criteria. Okay, so there can be a number of filters you can apply, right? So ultimately this filter itself is going to return you a stream. Okay, then we'll look into the map elements. So you're going to map those particular elements to different forms, so you can transform them from one form to another form using the map method. You can sort as well based on comparator, right? You the default sorting mechanism, or you can use your custom sorting mechanism that can be used up. You can also reduce your element into some one single element or value. Basically, let's say you have a number of elements and you wanted to sum of this particular value, or you want to average, right, or count or something like that, so you can reduce this as well. You can also collect the result into the new collection or the structure, so maybe it into the map or into the list or any other things. So you wanted to convert from an array to an list, right? You can do that. Now let's understand the basic concepts. So when it comes to stream is basically three operations. So one is that when you convert any input to an stream, right? There is a pipeline created. So stream consists of it is taking the input from the source, like it can be collection, it can be an array, it can be a generator function. So the series of intermediate operation, the terminal operations are performed. So intermediate operations are lazy because they are executed lazy, meaning they are not processed until you definitely call the terminal operation. So that's what the performance optimization when it comes to using the streams. So intermediate operation, when you can perform operations like filter, map, sorting, okay, which is an intermediate operation that is going to return a new stream. So you might call in the combination of filter, map, and sorted as well, and then ultimately it is definitely going to return a string. Now these are called lazy because they don't execute until we call the terminal operation. Now that's the benefit. uh, so terminal operations are like for each, collect, reduce, count, where you're ultimately trying to come up to a conclusion, or you want an end result. That is what the terminal operation is. Now there are different, it triggers the processing of the stream, and also ultimately it is going to give you a result. Now this is where the actual operation happens, right? Where even though you write some multiple intermediate operation, until you call the terminal operation, nothing is going to happen. Now let's jump into the practical things. We'll look into them one by one. Now first we'll look into the the basics creations of the collection. So basically the input would be the collections array or something, and we'll be basically convert them to a stream. Okay, so stream is going to be created from various sources, like you can give the collection, you can give array, you can give input output channels, right? So we'll create those. So let's jump into the code. Now I've opened the IntelliJ IDE. Now the very first example what we are going to look into is the stream example. In this actually I've written a list of string. Now if you see here, the input is array, like we have created an array list. Okay, so we are converting that to the list now. So we have created with the help of this particular arrays.as list, and we are going to add these elements. Now ultimately if you see here, I'm going to call the stream on this top of this. So the very first thing, whenever you want to perform some operations with help of the Java streams, right? So you need to convert that into the stream, whatever the input source is about. Now if you see here, this is the input over here. So list is the input, and we have converted into a stream. Ultimately this is going to be the terminal operation. Now if you see here, this is the for each, right? So this is the terminal operation, and let's look at by running this particular code. Now you will see the output is like, it is printed like Alice, Bob, Charlie, and David. This is the output. Now, as we already spoke about, there are different ways using the array, right? So now if you see, the input is numbers of array, and if you see here, I've ultimately converted into a int stream. Now this is one of the stream format, which is basically the integer. So I've converted that into a stream, right? If you see here. Now there is another way of converting. Let's say you have string of array. Okay, you have different ways to create it. There is stream dot off, which is ultimately going to return the stream if you look at it here. Okay, now there are different, like you can also make use of the generate method. Now you have some random number to be created. Let's say you have some limited till 5. Okay, so the random number we generated, and then it will be ultimately creating a stream of double over here. Okay, that's one way. Now we can also create using the help of iterator. Iterate, that is using the iterate, and then it is going to iterate from 0 to this particular thing, and we have a limitation over here as a number 5 over here. So in this way, this many way we can create the stream. So whatever might be your input, you can create this. I hope this example is clear to you. Now filtering, right? So as I already mentioned, the intermediate operation filter. So you can once your collection or any of this particular thing is converted into a stream, you can make use of the intermediate operation filter. Now this is going to take as an predicate. So this is one of the function which is going to return a boolean value. Okay, so the condition which is going to be satisfied, those will be filtered out for the next, and it will be passed on into the stream, and then will be available for the next set of operation. So this conditions has to be met. Now let's jump into the, now let's open the code for filtering. Now if you see here, I've created an string class with a filter. Now ultimately if you see, I have a list of array. Okay, with this list of string basically. So I have names over here. Now I've converted this to a stream. Ultimately if you see here, I'm trying to do some filtration where I want certain uh, names which should be only starting with A. Now if you see, there is only one uh, value which is going to be shortlisted and coming up to the next stream, right? And it is going to be print. Okay, so rest everything will be skipped up, and it will not satisfy the condition. So ultimately the stream will be created of only Alice, and then it is going to print. Let's try to run this and see. Now if you see here, that's what the output is. Now mapping the elements into a string. So there is an operation which we can perform on each of this element. So we make use of the map method, which will be converting into a totally new form of a stream, right? So example, you want to convert all the names to the upper case. So in that case, we are going to perform one by one operation on each of this particular element. Okay, that's how we can perform it. Now let's open the mapping class over here. Now if you see here, we have a list of names over here. Now here, as we already discussed, first we need to convert it into a string. Then ultimately we need to do some operation. Now as we discussed, I wanted to convert each of these particular elements to upper string. Okay. Now let's run this and see. Now if you see, all of them are printed in the uppercase. So in this way, you can perform lot of combinations over here with this particular map operation. Let's say you want the length of each particular element, right? So you can perform the length over here. There can be different set of operations which you can perform. Sorting. Now this is one of the another intermediate operation. Now you can sort your element, which is you have, once you convert it to a stream using the sorted method. Now which is going to ultimately return another stream which is sorted in the order. Now let's open the example of sorting. Now if you see here, I have elements over here. Now I am calling the sorted element. Now if you look at this, right, it is going to be converting into the intermediate operation, right? So and then it is ultimately going to perform that. Now let's look out this particular thing. Ultimately it will be sorted in the natural sorting order right now. If you see here, let's run this. Okay, so you can see it is sorted in the natural sorting order, right? I hope you are getting the coding examples and there is no confusion. Reducing, as we already discussed, I wanted to perform on set of elements, right? I want to reduce it, or I wanted to concatenate something, or I want to sum up something. That can be done using the reduce method. Now this is method is like a binary operator which takes as a binary operator, like the function that combines two elements basically, right? Let's look at it. Right, now if you see here, we have the list of elements over here. Now totally, if you see, I wanted to reduce it to the total number, the length of the names, right? Now if you see here, ultimately I'm trying to perform that particular operation over here. Okay, and ultimately on each of this particular I've taken the length, and also I'm going to reduce to the sum of it basically. Okay, so first I will convert this particular things to number of what is the size of it, length, and then I'm going to ultimately sum it. Okay, so I'm going to get one single value, that is 20. Now ultimately, like let's say you have some input, let's say you are wanted to perform something, and also ultimately you want to collect it into some list or set or map, right? So you make use of this particular collect method, which is ultimately a terminal operation. So you're trying to accumulate this element into a stream, and then ultimately it is going to convert it into some sort of list, set, or map. Now let's look at this. Okay, now if you see here, uh, this is one of the list over here. Okay, I've taken the input of the list, and then ultimately if you see, I'm trying to convert that particular thing. I'm trying to filter those elements which are ultimately greater than third row. The size is greater than 3, and then ultimately I'm going to again convert it into a list, right? So again, the input is a list, and also the output is list, but it's a new list which is filtering something. Now if you see, the Bob is missing over here. I hope this example is clear. Now I wanted to combine the multiple stream of operation. Let's say you want to do some chain of multiple operation together, right? Let's say you wanted to filter, you want to map, you want to do sort the names, etc., right? That's what we wanted to achieve, right? So how do we can do that? Let's look into it. Okay, now as we already spoke about it, right? So if you see here, the filter is being applied here. I'm going to perform the map operation, then I'm to performing the sorting, and then ultimately I'm going to fill into the list. So there are different chains of operation I'm trying to perform. These are all intermediate operations, and then I'm finally I'm trying to perform the terminal operations over here. So this is called the chaining operations. Ultimately, there should be some benefit, right? Why do we make use of stream? Just for the sake, right? Not sake of it, right? So the reason why we use Java stream is that it's conciseness, right? So you're performing operations like filter, map, and reduce. So it is going to perform some complex set of data transformation within one line or two line of code, right? So it is going to be a concise code of it. Readability, this is much more declarative, much more focused on what you need to do and not on like how to do, right? Internally it is taken care, but what you need to achieve is taken care in a declarative way. Parallelism, now the stream can be converted into a parallel stream. We can take the advantage of multiple core or the processor of the system to perform your operation in a short period of time concurrently. Okay, that's the benefit. Now, as we already discussed, there are parallel streams. So if you wanted to, the data sets is large, right? And you wanted to take the benefit of the parallel processing of the streams by making use of, parallel stream method. So this is not, may not always give you a better performance, but it is going to depend on the workload and the size of the data set, also the core system, the number of cores in your system. Now let's open the program over here. Now if you see here, earlier we used to perform the normal stream, which was used to be the random stream. Now I'm calling the parallel stream over here. I'm performing some operation like and then I'm trying to sum it up, right? Ultimately, if you see, okay. So this is how we make use of this particular parallel stream. I hope this video was very helpful to you. In this video, I covered up both practical and the theoretical concepts of what are the intermediate operation, what is stream, what is intermediate operation, what is terminal operation, what are the different set of intermediate operations, methods we can make use of. We looked into the code as well, right? How we can achieve that. So if this video was very helpful, please share it with the needy people. I'm expecting 500 likes on this particular video. Of course, like if this video was very helpful, please don't forget to like, subscribe, and hit the bell icon, and keep watching.